here's two triangles. They're two right angle triangles.
Uh-huh.
And we're going to say that the hypotenuse of these two triangles is 1.
Okay.
The hypotenuse is 1.
Okay.
This one is going to be a 45, 45, 90 triangle.
Okay.
And this one's going to be a 30, 60, 90 triangle.
Okay.
Now I'm using degrees. You could also talk about radians.
Radians,
Instead of
okay.
45, you could go pi over 4.
Sure.
Instead of 30 degrees, you go pi over 6. But let's just talk degrees now to
That sounds good to
make
me.
it easy.
That sounds good.
Okay. What we're going to talk about today is what are the lengths of these sides
Mm-hmm.
after I've locked down the hypotenuse to
Yes.
1.
Yes. And once we have the angles too.
Right, yeah.
Yes.
So the way I would do this
Uh-huh.
one is, since it's an isosceles triangle,
Yep. Those
these
sides
two
are same.
sides are equal, so I'm
Yes.
just going to call them x and x.
Sounds good.
Now, Pythagorean theorem,
Uh-huh.
one side squared plus the other side squared is equal to the hypotenuse squared. 1 squared is 1.
Okay.
So x squared plus x squared, that's 2x squared
Uh-huh.
equals 1.
Uh-huh.
That means x squared is equal to x squared is equal to a
1/2.
half.
Uh-huh.
And now I'm just going to square root both sides.
Uh-huh.
So x is equal to
Mm-hmm.
plus or minus, but it's a side of a triangle.
Yeah,
so.
it's a length, so there is no minus, okay?
So I'm going to square root. And that means that this side,
Uh-huh.
let's erase that, because and now I know that x is equal to 1 over root 2.
Uh-huh.
So that 45, 45 triangle
Mm-hmm.
has two sides equal to 1 over root
1
2.
over equal to. Okay.
That's the way I would do this triangle.
Yeah, that makes sense. Total sense. Yeah.
So now let's do the other one.
Sure.
How would you do that one?
So, same idea. I mean, I guess because we don't know whether one side, we know that the sides are not equal now, right?
Right.
So we will have to go x and y,
Okay.
and then x squared plus y squared equals 1. But then how do we go about solving for 1?
Yeah, because that's going to give me one equation with two
Unknowns, yes. I could.
A thought is,
yeah.
just an idea, because this one worked out nice. The 45,
Yeah.
45 worked out nice because
Yeah.
it was isosceles.
Yeah.
If I were to sort of
Yeah.
mirror this, now my drawing is bad, but pretend
just-
I threw another 30, 60.
Just flip it over that vertical line.
Yeah.
Yeah.
And now the whole triangle
Is-
is equilateral.
Exactly. So it's the same. So those sides are 1. Okay.
Okay. So you were doing X and Y here.
Yeah.
Now that X, what you said was
Uh-huh.
X,
Uh-huh.
that should be a half.
Half.
I'll
Exactly.
still keep your Y.
Yeah.
Okay,
Yep.
now what?
Now we can use 1/2 square plus y square should be 1.
Okay, 1/2 squared plus Y squared is equal to 1.
Mm-hmm.
Oh yeah, now I only have one
One
variable.
variable. And,
So
yeah.
let me catch up to you here. Going to subtract a quarter from both sides. Going to square root both sides. Same thing with the plus or minus,
Yep.
right?
Yeah. We don't have to worry about negative because it's the length of something.
Yeah. So now this is root 3 over 2.
Two.
So now I'm going to need to, I need a lot of erasing here. But I'm just getting rid of all these. We use Pythagorean theorem twice,
Yeah,
and I'm going to
twice.
have to put that half back.
Yeah.
Okay, wait, does this make, yeah, this does make sense, right?
Yeah.
Because 30 is the small angle.
Yeah.
So the smaller
Small
side.
Yep. Radical
is
3
opposite.
Radical 3 is about like 1.7.
Yeah, okay, so then that's like literally 1.7 times bigger than the
exactly,
half. So it
exactly.
makes
Yeah,
sense.
yeah.
Big angle, big side,
Big
small
side,
angle, small
small
side.
side,
Yeah,
exactly.
okay, that's cool.
Yeah.
So what we've got then is we've made these two special triangles,
Uh-huh.
30, 60, 90,
Yeah.
and, or no, 30, 60,
Yeah.
90,
Yeah.
and the 45, 45,
Yeah.
90.
Yeah. So now, if you are thinking about the unit circle, right, because the hypotenuse is 1, right? If you were to kind of imagine the unit circle and placing that triangle into the unit circle where let's say that 60 degrees is at the origin.
Okay. My drawing is terrible, but
But
that would
no,
make
no, that
this
ca-
a 30 degrees, right?
Yes, yes. So now, you get the size of that triangle, like, or the length of the sides of that triangle. It should be 1/2 along the, that should be radical 3/2.
Because you said unit circle.
Yes.
So that means the radius is
Radius is
1.
one.
And that's what the hypotenuse is.
Exactly. So that point you marked on the circle there, the coordinates are 1/2 radical 3/2.
Okay.
Right? And we can presumably use this idea to get the cosine and sine of these angles.
So cosine of 60 degrees
Yes.
is going to be equal to the
So,
x value.
X value. So cosine is the adjacent side over hypotenuse. Hypotenuse is 1 in this case. So it's just going to be 1/2. And then sine of 60 is going to be radical 3/2.
So I can see the wisdom of making the hypotenuse 1 kind of twofold, right?
Yeah.
It fits exactly into the unit circle.
Sure.
So the hypotenuse is the radius.
Sure.
And also when you were talking about cosine is adjacent over hypotenuse, when you're going over, when you're dividing by, you're always dividing by 1. So
1,
it's-
exactly.
the math is really easy.
Exactly. And there is no reason why, if we were to do more work, if we were willing to do more work, we could make the circle bigger if we want to, and still get the same ideas, same things.
Right, if you were to like double everything,
exactly.
then the hypotenuse would be 2.
2.
I think I've seen some teachers, they don't like the root 2 on the bottom. So
Yeah.
you as a viewer,
Yeah.
you might have seen this triangle, I guess literally a similar triangle,
Yes.
scaled up. They would have taken this 45, 45, 90 triangle and multiplied everything by root
radical
2.
Yep.
So there, okay. The triangle you would have seen would have been 1, 1, root
Radical
2.
Yep.
For reasons of, sometimes people don't like the square root signs on the bottom.
Yeah, I don't mind, but that's just my preference.
Right, and I agree with you.
Yeah.
Because it fits into the unit circle and
Yeah.
the divided by
Exactly.
hypotenuse is 1.
Exactly.
But
Exactly.
just to connect with things that other people have seen.
Yeah.
Oh, my
Exactly.
drawing is bad. The connect with things that other people have seen. I don't know, when you went to school.
Yeah.
When I went to school,
Yeah.
you'd do your back to school shopping, or your mom would do the back to
Yeah,
school shopping,
yeah.
and she'd buy a geometry set.
Uh-huh.
Back home it was called like Kilroy's or something.
Okay.
But it would come with a compass.
Yeah,
It would
yeah.
come with a protractor.
Yeah.
And it came with 2 plastic triangles.
Yes. Yes.
And I think we got it in elementary school, and
Uh-huh.
they didn't tell us what the triangles were, but the plastic triangles we got were literally the 45, 45, 90
Yes.
triangle and the 30, 60, 90 triangle.
Okay,
But
yeah,
we never,
I remember. Yeah.
We never used them.
No, we were called camel boxes. Like it had, it had everything you mentioned, and I never, back in those days, I wondered what are these triangle-looking shape things for. I used to draw triangles, but I didn't know what else to do with those.
And did you get they were called we called them the dividers?
Oh yeah,
They were just the
exactly.
two-
Yes, yeah. I think later when I was taking geometry class, like you can measure those, right? If I want to measure exactly how long a line is, or go around the circle a little bit, I can fix it and then just go around the circle.
Oh, okay.
Yeah.
Our teacher took those away from us right away because people were stabbing
Stab.
each other. We were just allowed to have the compasses, the triangles, and the
Yeah,
protractor.
the compass has one sharp edge too.
It's true, but I guess she made that way. There was like half the stabbing. All right, cool.
All right.
So
Yeah.
we made the special triangles.
Yeah, and one cool thing about this is once we know these two triangles, we can get cosine and sine of every major angle just using these two triangles and using the unit circle.
So that
Placing-
should be another video.
Exactly.
Okay.
It will be too much for this video, but we should make the next one.
Cool.
Yeah.
All right.
Yeah.
See you in the next video then.
Sounds good.